Another interstellar visitor to the Solar System. The comet can be seen with the naked eye. In September this year, we will have a unique opportunity to see the comet Nishimura, which is probably from outside the Solar System. Unique because it belongs to those comets that only come to visit us in the night sky. However, it will be exceptionally well visible and will most likely be observed with the naked eye. The object designated C2023P1, Nishimura, discovered just a few days ago by a Japanese amateur astronomer, is a comet that is believed to have come from outside the Solar System. Its hyperbolic orbit suggests this, but astronomers currently don't have enough data to say with 100% certainty. The comet will most likely leave our planetary system, but before it does, it will become bright enough to be observed with the naked eye. This comet was discovered on August 12 by Japanese amateur astronomer Hideo Nishimura, after whom it was named. It probably comes from outside the Solar System. If true, it would be the third known object of its kind after the famous Oumuamua and 2I, Borisov. However, other possibilities are also considered here. The comet could also be in the Oort cloud, already beyond Neptune's orbit, hovering on the outskirts of the Solar System, eventually being pulled by the Sun's gravitational field. It has already been observed that its braid takes on a greenish color, which is associated with the disintegration of diatomic carbon molecules under the influence of solar radiation. According to the observations made so far, its orbit is hyperbolic, which means that by flying near a larger object, such as our Sun, it can gain enough energy to use a gravitational slingshot to break free from its gravitational field. However, there is some risk here. According to some scientists, the force of this gravitational slingshot may turn out to be so great that it may even be able to tear apart the nucleus of a comet. Comet Nishimura, however, will most likely be ejected into interstellar space. Therefore, her next visit to our planetary system will be the first and at the same time the last one that will ever take place. It is even more worth not to miss the opportunity to see it. As it gets closer to the Sun, it will become brighter, and the best conditions for observing this comet will be in September. It will be closest to Earth on September 12. It will then be about 125 million kilometers from our planet. It will be closest to the Sun on September 17 and will enter the orbit of Mercury. At present, Comet Nishimura is bright enough to be observed with home telescopes. However, during its closest approach to the Earth, it will be visible to the naked eye. It will be easiest to spot just after sunset or just before sunrise. This will be due to its position in relation to the Earth. The eruption of the Hunga Tonga volcano was more powerful than the explosion of a car bomb. In January 2022, there was an underwater eruption of the Hunga Tonga volcano. It resulted in the occurrence of a powerful tsunami wave, which fortunately did not turn out to be as destructive as the one in 2004. However, this eruption itself released so much energy that its force can be compared to the most powerful detonated nuclear bombs. Researchers at the University of Sheffield have determined, using data from weather stations around the world and comparing it with historical data, that the Hunga Tonga eruption released more energy than the largest man-made nuclear explosion to date. According to new analysis, the eruption of an underwater volcano was more powerful than the detonation of a Tsar bomb. The description and results of the research were published in the magazine, Shock Waves. The eruption we are talking about took place on January 15, 2022. Then the Hunga Tonga Hunga Hapai volcano erupted. The resulting acoustic gravitational waves reached the edge of space. They have even been recorded by satellites and instruments in various parts of the world, including in the UK. In this country, they have been observed at weather stations from London, through Fife, to the Scottish Highlands. What we managed to see in all these stations was a passing pulse of pressure. It caused the local atmospheric pressure to suddenly increase and then drop sharply. The observations were also significantly helped by enthusiasts of this type of observation from around the world, publishing information about the recorded pressure and the moment when the pulse began to pass, and of course the location. It was therefore an interesting case of joining forces by the world of science and amateur observers from around the world. Returning to the pressure impulse, in the case of the eruption in question, it took about 45 minutes to return to normal conditions. It would be interesting to compare it to earthquakes, in case of which the entire observation usually lasts from a few seconds to a maximum of several minutes. Researchers from the University of Sheffield undertook to collect data obtained from weather stations around the world and from social media. They then compared them with historical data on nuclear tests conducted on Earth. The aim was to make a comparison of the amount of energy released both at the moment of the eruption of the aforementioned volcano and during the detonations of nuclear bombs that have taken place so far on our planet. It turned out that the Hunga Tonga volcano can really explode powerfully. As stated by Dr. Sam Rigby from the University of Sheffield, the eruption of this volcano was one of the most energetic events we have seen in the last century. At the same time, It was so powerful that the amount of energy released was not only comparable to the explosions of nuclear bombs, but even surpassed them. As a reminder, the most powerful nuclear bomb ever detonated on Earth remains the Soviet-built car bomb. Its strength is estimated at 50 to 58 megatons of TNT. Although it was originally planned to be as high as 100 megatons. Meanwhile, in the case of the eruption of the Hunga Tonga volcano, we were dealing with an explosion force of 61 megatons. The energy released was comparable to an earthquake with a magnitude of around 8.4.